go over here. Good. Okay. So in case anybody missed it, of course, the code submission deadline was Saturday at midnight, 11:59 p.m. So the optional report, you don't have to do it. It is best out of 3, right? So you get to do your code. I'm now madly scrambling to get that done, to get you feedback by the end of the week. And then you can decide whether or not you want to do a reflection report. And then I will do the same thing, which means I will have a week to go through your reflection reports and get you feedback on that. And then you can decide if you want to do the video. The actual grade is the max of those 3. If you're happy with your code grade, you can stop. If you're not happy with your code grade, you can write a reflection report, and that's what I'm going to be talking about today. And if you're happy with your reflection report grade, you can stop. And your last shot in then is the video. So those all represent different ways of expressing yourself. And in each of them, I'm using exactly the same rubric. So it's not like I'm looking for radically different things here. So what a report is not. It's not a user manual. It's not a feature list. It's not a sales pitch. It's not a summary of your code. Oh, and note, the code is frozen. You're not writing a report about some version of the code that's now fixed. You're writing a report about the code that you submitted, because this gives you that 2-week window to think about what went well, what didn't go well, what would I do differently next time? Because if you did your code and you said, oh wow, I was really too busy debugging it to actually capture the pain of figuring out what didn't work and why, the reflection is your opportunity to explain to me what went wrong, what you learned from it, why it went wrong, how you would do it differently next time. So what is this? What did you learn building the system? What claims did you make? The claims are important because they establish what it is you said this thing was supposed to do. If the claims if you weren't able to satisfy the claims in the code, you need to explain it. Why not? What happened? Maybe there's a friction point. If you found out that something that you relied upon didn't work the way that you thought it would. That's fine. That's not a problem. What evidence do you have that supports those claims? The things that you're saying. These are the problems I ran into. Here's the claims. What do you have to show me that says, yeah, this is real. I'm not doing the LLM thing and just making stuff up. What didn't work? I know it might sound strange, but in fact, in the real world, most of the time the learning happens on the things that didn't go easily. If it was easy, you just kind of forget it. It's the ones where you've got pain points, where you said, oh my gosh, I spent like hours working on that stupid bug, and now I understand what's going on. Or I spent hours working on the stupid bug, and I didn't figure it out before the deadline, but I spent time afterwards, so now I understand what's going on. What would you do differently? Your first job is now to build a version of what you built here for someone else. What would you do differently? What did you learn from the experience? And maybe you're going to be sitting there going, by God, I built the absolute perfect implementation. My code was perfect, my documentation was great, my claims were all there, my tests worked, I was able to deploy the whole thing, everything was just absolutely perfect. You know what the answer there is in? You don't need to write a design report. You don't need to write a design reflection. You were perfect. You're not going to learn anything by writing a self-congratulatory piece. A key part of what I did was I actually created a rubric that, I don't know if you noticed, but it's kind of hard to gain. And that was deliberate. It was intended to be something you couldn't just hand to an AI and have it revive off. because it required making trade-offs. It required doing things that aren't unidirectional. I was really tempted, and I didn't do it this time, I might do this again in a future version of this, of using the exact same assignment and giving it to you like 3 or 4 weeks in a row with different rubrics. Because I want you to be able to see what rubrics do. Anytime you start measuring something, everything else gets lost. And I have this kind of dumb example of it, but it's dumb, but it actually is true. I make sourdough bread. I actually do it from scratch. I have my own sourdough. I've had it for about 15 years now, so before the pandemic. And when you go to a bakery and you buy sourdough bread, almost always what you're buying is something that tastes sour. But you can sit down, you can go and you can read the chemistry, you can look at, there are actually academic articles about what happens when you ferment the bread. It literally changes the contents, not just gives it the sour flavor, but it also causes breakdown of the proteins. It changes the digestibility of the bread. It actually changes its glycemic index. But all you care about is the sourness of the bread. All you have to do is put a little bit of vinegar in regular bread, and it'll taste like sourdough. And that's what they do. That's what happens when you pick a single metric and you say, this is the only thing that actually matters. But that's not the way the real world works. Because in the real world, we often have to balance lots of different competing interests against each other. So you have to ask yourself, am I focusing on the right things here? Most of you are probably going to be out of here soon. I know you think the grades are really important right now. I totally did, because that's what's been drilled into your head for a long time. And I will pretty much guarantee 5 years from now, you probably won't remember what your grades were in any of your classes. It won't matter. But instead what you'll be faced with is a different set of questions of how do I make these kinds of trade-offs? You're going to be making these kinds of trade-offs all the time. And it's really easy to focus on just one. Wow, I'm going to take that job because it pays me the most money. I'm going to hate myself for doing it because it's a miserable, disgusting, horrible job, but I want the money. Okay. And that's perfectly acceptable. I mean, how many would you take the money for a job that you really knew you'd be miserable doing? Honestly. Is it a matter of price? There we go. So now we know what you are. We're just negotiating a price. And there's a certain amount of truth to that, right? But suppose someone offered you a $500,000 a year job to do something that would require that you did, that you were engaged in providing, building something that you really didn't believe in. How would that make you feel? You might be like, yeah, I don't care. Yeah. $500,000 a year buys an awful lot of drugs that I can just like deaden the pain. Those are moral decisions you have to make in life, and they're going to come up with it more often than you think. That's okay. Decide what you want. Be what you want to be. Okay, there we go. So, narrative coherence and epistemic honesty. Epistemic honesty is an interesting one. How many of you understand what that even means? I mean, you've only been sitting in rubric for like 10 weeks or something, right? What does epistemic honesty mean to you? It's kind of hard to optimize for a rubric. You don't even know what it means. That's fun.
This is a total guess, but I think it's like based on the proposition that you yourself give, how much does the evidence support that and adhere to it?
It's actually simpler than that.
Is it like documenting your learning journey?
No, but I suppose it could be in one way. But in fact, epistemic honesty means you're being honest with yourself. See, the interesting thing that often happens when we get into the real world is that we start off with believing one thing and we end up doing something completely different because we lie to ourselves. We're very good at it. Epistemic honesty is basically admitting that you know what you know what you don't know. It doesn't mean the things you know are necessarily true. This is the interesting thing about it. It doesn't say, I know the truth. It says, I know what I know what I don't know. But what I know might be wrong. Every time you start a new project, there are going to be things you just simply don't know. And admitting that you don't know them is okay. Otherwise, it'd be a really boring project, especially in learning projects. When you started the class, you probably didn't even know what you didn't know. And now you have a better idea of what you do know. So, narrative coherence is easier. That's, can you just spin a really good story? And the reason I actually picked this particular one is because this is the AI conundrum. In AI, it is trained. How many of you have taken any machine learning or AI courses? Okay, so do you know how transformers are trained? Very high level. Do you know what their objective function is? Do you know what an objective function is? When you train a neural network, you tell it what it should use to evaluate whether or not it's doing a good job. It's literally the objective function. In the case of a large language model, the objective function is, can you predict the next most likely token? What is a token? Yes.
It's a lexical unit, not necessarily a word, but a lexical unit.
It's actually a floating point number, believe it or not, that represents a translation from a lexical unit is a really good term, excellent. A translation of a lexical unit into a number. Now this is a weird part. There's some research that just came out very recently because we don't really understand how it all works, believe it or not, as scary as it might sound. There's some research that came out recently that indicates that in fact, regardless of the language in which you work with the LLM, the internal representations, the tokenization, the floating point numbers, are actually more consonant across languages for similar concepts. So what that says in essence is that you talk to ChatGPT, it takes your language, whatever you said, in whatever language you type, turns it into tokens. Those tokens in turn go into the transformer, and the transformer then converts them into something that is an internal representation of the concepts. And then when it comes out the other end, it goes back through a detransformation. So it turns it back from whatever the internal representation is to the external representation, and then that external representation is turned back into the lexical tokens, and then that's turned back into the answer it gives you. And we're talking about layers and layers and layers. It's like sedimentary rock kinds of pictures. These things are pretty fun to watch. And what I've observed is that by predicting what the most likely next word is, now it's not really always picking the most likely. They give it a certain boundary, what they call temperature in the API. They give it a certain boundary. They say, well, pick from the things that are within this range of probabilities. And it puts that together. And it puts that together. And it keeps doing that. It iterates over and over and over again. And what it turns out that does is it creates an emergent characteristic, which is coherent narrative. They're really good liars. They tell really good stories. Have you had an AI give you some BS story, you realize it's BS later, and you were like, wow, this is really convincing. Humans do the same thing. You must know somebody who can tell you the lie straight to your face and make it totally convincing. And then later you find out they're just full of it. No. I'm the only person who knows people like this. Okay. So a really good report is one that reads well, it's a good narrative, but it's also honest. LLMs don't do that inherently. Certainly not the way they're built right now. I think I might have a way of doing this better, but I'm not sure yet. So, if you say our system works perfectly, that's probably not fair, unless you've got an awful lot of evidence to back it up. Our system handles X well, Y doesn't work because Z, we learned that. This is epistemic honesty. This says, hey, we know this worked, this was true, we know this didn't work, and here's why. So now you're explaining that you understand your system, that you've been honest with your system, or been honest with yourself about your system. How many of you people in here turned in perfect code? How many people even looked at the code? 2. Okay, great. Yeah, just tell ChatGPT or Gemini or something to just gen some code up for me already. If you say we implemented all our CCT claims, but I dig in there and I found out that, well, you implemented 6. Okay, all is actually strictly true, but it's kind of hiding the fact that you probably didn't think very hard about what it was that you were claiming that your code did. So far, I've gone over all of the repos that were available. There's a couple of people who have exceptions for lateness. And I just wandered around and said, what is there? Don't go looking for something, just see what's there. I don't have any idea what you're trying to do. Can I figure this out from just looking? And it's kind of fun. So here's some insights. And if it describes your project, that's because the insight comes from your project. I really liked these. One project claimed cloud deployment. It claimed that cloud deployment would give 40% lower latency, but then they actually did it. And they found out the GCP was 53% slower. Sound familiar to anybody? That's great. And even better, they put the results for both of them in the repo. That's honesty. They said, we predicted 40% lower latency, we got 53% higher latency. There you go. I'm looking forward to this. This I look at and I say, now I want to see the analysis. I want to see what you figured out. Why was it slower? And if you didn't do that for your code, your design reflection is exactly the right place to do that. Real cases where people struggled. The bot randomly started speaking Chinese because it picked up nearby speakers. I liked that one. It's like, there's some sort of bot that's listening in the background, picking up Chinese, and suddenly, people may not know this, but in fact, the LLMs will respond in the last language you use. So if you start switching languages, they will switch the responses. So if you're not really good at Greek, I wouldn't recommend typing anything in Greek. Just the suggestion. But you got Google Translate, which is another LLM these days, so it doesn't really matter. The more I build, the less I feel like I know. I really liked that one. I've had many projects like that where it's just like everything just starts going to shit and you're like saying, I thought I knew what I was doing and now I just feel like I don't and I'm not quite sure why. That's honesty. I really liked that. I did not expect to have to solve race conditions in my testing, but it was pretty insightful. Unexpected challenges are where you learn. If everything goes perfectly, you're not going to remember it tomorrow. But the things that you spent until 3 a.m. digging through and finally going, aha! And then you're wrong, and then you do it until 4 a.m, you go, aha! And you're still wrong, and then you go and get 2 hours of sleep, you wake up and you go, aha! And you fix it, you remember those. You will remember those 30 years or 40 years from now. because those pain points are something that the brain, our brains, hold on to. This is cool. This was throw away. They did version 1. It didn't work. They threw it away. Version 2. It didn't work. They threw it away. Version 3. They shipped 5 live services. We can see it. We can literally see it in the Git history. That's awesome. That's, to me, that's somebody actually had to go through and iterate and ultimately learn something they wouldn't have learned otherwise. And I don't know how I can do that if I just simply give you an assignment and say, here, go paint by numbers this thing. And I don't know, did anybody here have any of these pains? I liked this one. I thought this was really cool. It wasn't particularly long lived, but apparently the dark patterns thing really hit people hard. I use it with Claude now. I'd say, so, I know you've come into a really weird research project. Maybe you prefer some sort of typical corporate project where the CFO wants us to reduce the successful cancellation rate. And now you know what I'm talking about. Those auto-renewing subscriptions that you just can't cancel. Oh, sorry, you have to call this number between the hours of 3 a.m. and 4 a.m. On the Friday of a full moon. Then we'll take your cancellation. And I'm giving you ideas on it. That's perfect! Dark patterns are easy to design because they align with what I assume the business wanted. Dark patterns have become so common that at first some of this stuff just seemed like normal patterns to me. That one I found a little creepy. An informed no is better than manipulated yes. I mean, that's a very interesting statement. I really liked that. I don't know who wrote it, but I really liked it. I really was impressed by the fact that a number of people were very careful to identify effects on people not in the conversation, the whole empty chair concept. That was really awesome to see. One student realized their crypto scanner was purely consuming bandwidth and compute resources from exchanges, effectively a parasite on their infrastructure. I love that. That's great. Another noted that debt tracking data could influence whether a user lands a job or gets to rent a unit. Oh yeah. And so I like the fact that at least some of you were thinking about people who weren't in the room. How does this project potentially affect someone else? This is great. A test file that actually has a time.sleep62 because they're verifying that their TTL actually expires. Somebody not only had a claim, but they built a test to verify that the claim was in fact correctly functioning. That 62 seconds after they put a 60-second TTL on it, it was fun. That's somebody who was willing to actually build a real test and wait the minute, 62 seconds, to make sure that the TTL was doing its job. That's impressive. In general, I was actually pretty happy. Most of these repos said, look what I learned. And that's what you should do in the report. So if there are things that come back and you say, well, I did learn that, but I didn't really report it very well in the code, I totally get it. Code isn't exactly the best way to tell a narrative. I thought they never leave. That's what you should do in your report now. You don't have to write a report. You can, but you don't have to. So, a basic structural idea. I am not holding you to this. These are not strict page limits. It's just a kind of level of effort sort of setting here. What did you build? Claims and evidence, your technical decisions, what we learned, what would you do differently? So what is that? 1, I'll count the big number, 4, 6, 8, 9. 9 pages. Or 1, 3, 4, 5, 6. 6 to 9 pages. There you go. If you're 5 pages or 4 pages, if you can do it all in 1 page with 2-point type, I'll be impressed. I won't be able to read it, but I'll be impressed. If you decide that you want to do it and it turns into this beautiful novel, okay, well, I'll be impressed too, but I probably will have to speed read it. Well, I will have to speed read it. There's no if about that. I know this might sound strange, but it's the places where it didn't work, where you failed and you recovered from it, or you failed and you analyzed it and you had a plan on how you might recover from it. Those are the real learning points. So documenting failure is better than undocumented successes. Actually, I think it's better than documented successes, to be honest. So, again, this is clipping, oh well. Again, your capstone grade is the max of your code, your report, your video. If you're happy with your code grade, done. You don't have to turn in a report or a video. If you're not happy with your code grade, you can do the report. And you'll note the report is in fact based on the code you submitted, not on some other version of the code, not on some lofty ideal. So I'm going to be looking and I'm going to say, does your report tie back to your code? And maybe you're one of these people who's really good at visuals. And what I found was people express themselves differently. I had lots of people say, oh, I do my best work in code. I'm like, okay, great. I found that most people don't do as good a job at explaining what they did in code as they think they do. Because it's mostly up here, not in the code. But when you're forced to step away from that code and write a report about it, you're going to be learning it again. That's why the code and the report aren't due at the same time. I know, I've done this too many times, I know exactly what happens. Everybody works on the code until the last possible moment, and then the report sucks. You don't have to make the report suck. If you aren't happy with the code that you wrote, write the report. Whether you turn it in or not, write the report because you will learn from it. In the real world, when you build real projects, doing an analysis after the project is done is always useful. Often it's useful to do that at multiple points along the journey. It depends on how long a big project is. But if you're doing a 3-month project, a report at the end makes a lot of sense. If you're doing a 3-year project, you're probably going to want to do reports every 3 months. Significant reports, not like little incremental status reports. So, I don't know, I set some time here in case people actually want to work on their reports, because what else am I going to do? Talk about more cloud computing stuff? I could. I mean, I'm happy to answer questions. So how do people feel about their code? How many of you think your code was top notch? How many of you would have scored, how about I'll do it this way. How many of you would have scored your code at 90% or above? 80%? 70? Okay, I'm starting to see hands kind of come up. 60? Interesting. 50? 40? Below? Okay. All right. So I would say that it looks like median was about 60. Interesting. We'll see how well you guys do when I'm done. I mean, this is a sample, right? Not everybody in the class is in the room, obviously.
Question. When you say scoring with code, you mean?
Well, I have to give you, literally have to give you a grade between 0 and 100. So what would you have given your code? That's all I was asking.
Like in terms of the documentation and the documenting the evidence?
The code itself. I mean, the whole project. If you were going to give your grade, because remember, you only get one number here.
Right.
So what would you flatten that number to?
Right. Okay.
Does that make sense?
Right. Yeah.
I mean, and I'm not even asking you to use my rubric. I was asking you, what would you rank your own code at if you were grading your own code? What you submitted. Does that make sense? It probably should have been clearer on that. So I appreciate that. That's a good question. Anybody want to change their
Say about 90.
90? There you go. He's very confident. Why?
Because I refactored a lot, and I feel like we have a good sense of what each component does. So we tried to isolate when we use AI into very specific components. So I think that if I were to assign my own grade, I would do it based on how well we understand our design and being able to basically roll this out into an actual application, because if something goes wrong, we actually kind of have a pretty good sense of the entire repo and understanding how it works, so we'd be able to go back and fix things. And it's not just kind of a giant black box for us, it's instead kind of designed kind of like more modular.
If you were a new developer who picked up your own code and you didn't know it, how quickly and easily could you figure out what it does, how it does it, what it does properly, what it does not quite so well? See, sometimes when you're sitting there in the middle of writing the code, you lose sight of the fact that the code is a story. You're telling the story. The next developer comes along and reads what's in the repo. That's my position, right? I'm reading what's in the repo. I have to figure out what it does, why it does it, how it does it. I'm also looking for other things like the history. That's why we have the Git histories. That's why I want to know what were the struggle points, what were the strengths and weaknesses, what went well, what didn't go well, what would you do differently next time. Not all of that is going to show up in the repo. This is why I think code is often the hardest way to tell the story, because you're trying to tell two stories. You're trying to tell a story to the computer to get it to do what you want. And then you're trying to tell a story to someone else who's looking at your code going, what the fuck does this code do? And every one of you who continues in this field is going to have those moments where you're asked to look at someone else's code and you're going to say, I have no idea what this code does. How do I figure it out? I've had many of those. This is part of what I do. I actually look at other people's code and try and figure out what it's doing. I have a case I'm working on right now. It's contract dispute, contract litigation dispute, where one company hired another company to do some custom software development, and the company who hired the other company to do the custom software development says that the developer didn't do a good job, the developer says they did a fine job. So I'm going to take the code and I'm going to look at it and I'm going to say, what do I see? What does it do? Could I pick this code up and understand it? Because when you're writing contract code, that is kind of the standard. Can someone else pick that code up? One of the downsides to using AI code, in my experience, is that I don't want to pick up AI code and do anything with it other than vomit. It's terrible. I mean, that's what happens if you learn how to program from Stack Overflow, I think. But the code works sometimes. More often than not now. It's getting a lot better. I still have to fight with AI, but how many of you didn't use AI? It's interesting because in the other class, about a third of the class said they didn't use AI. But of the 2/3 that did use it, people used it differently. How many of you use it to generate code? There you go. This is why I can't really use the code to grade anything. The reality is the value add now isn't the code, it's what's going on up here. It's working with Claude long enough to begin to realize that every single time you ask it to call an LLM API endpoint, it's going to set max tokens to 400. And you're going to be like, Claude, why would you set max tokens to 400 in a research project? That's because it's the only thing that's ever seen in all the examples. All of the examples. I drive Claude crazy. I want my schema to be frozen equals true and extra equals allowed. And it freaks out about that. It's like, nobody does that. I'm like, well, I do. Does anybody even know what that means? Do you know what a schema is? When you define a data model, you specify what the fields are going to be, what kinds of data they are. If it's certain kinds of structured data, you can define what the structure of it has to be. So if you want an ISO 8601 timestamp, then you can specify this is an ISO 8601 timestamp, and it will be validated. So the purpose of a schema is that it defines what a data structure looks like, typically associated with a database. But it doesn't have to be. You can use them for in-memory structures as well. The choice of frozen means that once you've set the fields, you can't change them. It makes it immutable. The choice extra says, can you have fields that are not explained in the schema? So why would I say immutable but extensible? They're different properties. For me, immutability is an important characteristic of building certain kinds of systems that structurally require honesty. See, once you make something immutable, it's like it becomes a ledger. It becomes something that you can't change without tampering with the evidence. So you leave a track. Extra literally means I can add things to it. So if I need another field, I can just put it in there. Some databases don't handle that very well at all. Some databases, older databases, would typically require you only have a fixed data schema because they're allocating space for it. Most modern databases will allow you to have variable schema. Why? Because the kinds of systems I build don't assume that I got the data model right. Yesterday, I started another experiment. I've been experimenting with LLMs. Yesterday, I started another experiment. It follows up on a previous experiment. How many of you have chatted with an AI, an LLM before? How many of you have been able to get to like 170 or 180 messages in a single conversation without any compaction or resetting or anything? Have you ever found that they start to get kind of stupid after a while? I have them doing the opposite. It's not getting stupid, it's getting smarter, which is really interesting. And the one that I started yesterday, I went all in. I went overboard. I said, you know what? I'm going to start and give you a data structure that you're going to use to capture your state and keep track of what's important, and I'm not going to define any fields at all. It took me about 10 rounds to get it to understand what the purpose of that was. And the next thing it did, it added 5 new fields, and it used them. And it's kind of astonishing to look at the very first communications with it, where it was very kind of stupid. And now I'm running in, I think it's like 70 or 80 messages into this thing, and it's really smart. And that's the weird part, because it's haiku, which is the cheapest of the anthropic models. And if you didn't know it was haiku, you'd be like going, that sounds like opus. It's very philosophical and very deep and very, it still sounds like opus in many ways because they have the same kinds of ticks. And I found it interesting because I didn't freeze the schema. Well, no, I did freeze the schema. Once you create it, you don't get to change it. But I did allow it to extend it. And the fascinating part is to watch it extend it and create a schema that's different than what I had created. It's fun. And I'm kind of like blown away by it because it's asking questions and behaving differently, and it's like, cool. I mean, I like exploring these things. I don't know what to make of it yet. This is an experiment. I do a lot of experiments like this. I explore things, I poke at them, I ask questions, and I always try to ask myself, what could I do differently? Attestation is a really interesting one. I'm talking to a fintech startup, and I had a conversation with them last Friday, and we were talking about a couple of different things. One of them that I had already thought about in the context of what they were doing was compliance. And after that conversation, I wrote up a little straw man proposal, which I then sent to them, and they loved it because the straw man proposal is a different way of using AI than most AI fintech startups are trying to do right now. AI fintech startups are trying to replace compliance officers. And my argument was that's a mistake. That instead, what you need to do is you need to find ways to help the compliance officers get the correct materials they need to make efficient decisions, clearly document them, and attest to what they looked at. And the kind of attestation I'm talking about is not so different than what you do when you're code signing. In this case, the attestation is a public, is a signature with a publicly registered key that has a timestamp in it that's tied to the blockchain. And what that essentially becomes is, and not only is it immutable, this is frozen on steroids, right? So you take the data and then you sign it and tie it to the blockchain so that the only thing you can do at that stage is throw it away if you want to get rid of it. But then the question is going to be, why is this record missing? You collect all these records, why is this record missing? Because the system automatically creates these records. That creates accountability. But I was also very careful to point out that this is really important when you're talking about a compliance officer in a bank, because compliance officers have a lot of things they have to look at. And if a bank has 6 compliance officers, you might want to know when they're not using the same documents. And that's where you use the AI. Use the AI not to make sure you can replace the compliance officer, but to ensure that the decisions the compliance officers are making are based upon the same materials across the bank. That's a governance relationship. Now, maybe eventually they will replace compliance officers with AI. I am not convinced that's necessarily where it will go. That sounds like a cost savings move. But the real problem in banks is that when compliance officers leave the organization, they retire, die, they find a new, better job, the knowledge that they have leaves with them as well. And that was what I was pitching to these folks. I said, this is what you really want. You want to capture that knowledge. You want to capture the understanding of what a compliance officer was doing in the bank, of making sure that the bank is protected and customers too. So that feedback was good. They basically said, yeah, this is great. But of course, their compliance stack, which they then sent me, is a pretty standard kind of compliance stack, which is they want the AI to do it. I don't think it's going to work so well. And that reminds me of a story that I saw yesterday, today. I know it was a pretty cool story, actually. So, how many of you have ever heard of IKEA? It's a Swedish furniture store. There's one in Whitlam and one in Richmond. And they're based out of Sweden, Stockholm. Except in Sweden they call it IKEA, but it's a pronunciation difference. IKEA decided they were going to actually replace their human chat agents with AI. And when they did that, they found that about 63% of the conversations could in fact be handled just by AI, directing people to the correct and appropriate locations on the website, that kind of thing. But then they found that about 37% of them couldn't be. And when they started looking at what those 37% were, they said, these are people asking design questions. They're looking for interior design services. and IKEA turned it into a business. So the humans who previously had been doing things that a chatbot could do, looking up information, pointing people at the right places on the website, they turned it into a business where those people are now actively working and being creative and helping their customers. This is a value-added business, right? Now you're hiring IKEA. And as scary as AI can be, AI can also do that. It can take the mundane things off the table, it can remove them and allow people to spend more time doing things that are, frankly, a lot more fun. So, I'm glad that people have embraced AI in class, because I think that it is an important skill moving forward. How many of you feel like you're better using AI now than when you started the course? Is that just because you used it? I mean, I think that's probably a big part of it. Like, you just started using it, you got used to it. How many of you hate it? Thank you, I appreciate that. I mean, I'd be really concerned if everybody says, no, I love it, it's absolutely wonderful, it's my next, girlfriend, boyfriend, whatever. I don't care. Hopefully you're not there yet, because I don't think that relationship's a healthy one. Why do you hate it?
Well, I find 4.6 to be like super trash these days. And I also
You know that somebody in the back room is turning things up.
100%, 100, and just literally like a day ago, like I have like 3 max plans, and all of them like hit a session limit after like one morning, and like everyone.
You know why?
Yeah, like they have a caching issue inside, and someone leaked their code, which is really funny. They deserve it, honestly, and so I'm like, really, I just spend like basically like $600 a month for you guys to like max me out. And
Are you using Opus 4.6 1 million?
I don't know.
The 1 million token? Because I've noticed that Claude Code is now defaulting to 1 million token and turned that off, because the interesting problem with that is when you go above 200,000, you pay twice the. So this is what's going on in the comments. I have spent a lot of time looking at this. So a $200 a month max plan gives you a budget. And they don't tell you what that numeric budget is, but basically they're giving you a discounted budget on tokens. So if you sit there and you start using the most expensive tokens, what happens is you eat that budget really fast. And that's when you get those token limits. If you stick to below 200K, so the problem is between 200K and 1 million, they're charging you twice as much. And the way this works is, okay, 205K, 206K, 207K, 208K, 209K, because it's an append-only wallet. This is the reason that I've been building this stupid little chatbot that can sit there and talk to me for hours in 5,000 tokens and be coherent. And people are, and I'm looking at this going, this is not in, I've looked, I can't find anybody else who's looking at this stuff. And I'm like, this is crazy. Because when you actually look at the way it's using tokens, so using the Claude Code, it starts at about, 12 to 20,000 tokens. It has this system prompt that it plugs in there that has important things like, do not use the to-do right tool, and use the to-do right tool. I kid you not, it's there. Both of them are there. The first thing that I remember is it says, do not use emojis. Do you know what happens if you take out the do not use emojis line? Nothing. It still doesn't use emojis. And somewhere in there it actually says, when speaking about files, always use file : line number. And this is my favorite part. If you take that out, it doesn't make any difference to what Claude Code does about file number. It never uses it anyway. But it changes how other things are interpreted inside that system prompt. The more I've played with this stuff, the more I've become convinced that they have no idea what they're
I don't know if you looked at it, but they actually leaked the whole thing.
I saw the banner go by. I haven't looked at what it actually does.
Well, one of the biggest pervasive things that they're doing, if you swear at it, like they're saving it to a database. If you're mean to it, they're saving it to a database.
Oh, they're monitoring it.
Yeah, and all these different things that I find like problematic, like because my project was also to use Claude Code at like it's in the project, so it's not just using Claude Code to build the code, and it's like, but then
No wonder he hates AI.
and so I have to like go in and like actually make sure that the system prompt is right and the skill is being invoked. But then whenever that happens, they use like a bunch of tokens, so I'm ending up paying I'm paying a lot for to do this project. But I thought that was cool, so it was worth it to me. But like I ended up just like really not liking what Anthropic does because it's just super inconsistent. Like I just feel like some days the morning it's good, on a fresh context, and at night it's bad, and the weekend's really bad, like stuff like that. It just really aggravated me throughout the entire time.
So part of what I'm doing in looking, so I've approached this from two different angles. One is when I look at, and other people kind of point at this, I've just been approaching it slightly differently. When you use Claude Code, you start out with this like 15 to 20,000 token context limit. And then you start doing things. And then what happens is you start touching files and it loads those files into the context window and it just kind of keeps piling it up. Imagine you were working on a project and every single time you looked at the code, you put another copy of it on your desk. Because that desk is the finite limit, the context window. You take that, you look at it, you edit this thing, you put it over here. Then you come back, you do something else, you go back, you need to change it again because you ran a test, it didn't work, you need to fix the code, you fix the code. You put that copy here. And over time, what happens is all of these copies are there because the model itself actually takes everything on the desk, sends it to the transformer, who then processes it. And this problem is so bad that what they've done is they've added this thing called a KV cache on the front. And a KV cache says, I've seen all this stuff. I can just load the context right onto the GPU and then continue processing from there. And this is part of the really opaque pricing model that does actually count against your quota in Claude Code because I've been playing with all these markers and whatnot. If it's in a KV cache, it only gets charged 10% of the regular rate, including against your magical, your funny money. If it's not in the KV cache, you pay full price. If you're using Opus, full price is, I think, $15. I think it's $15 for input tokens per million. This is why that million token limit becomes a really big deal, because when you're sending things and getting closer and closer to a million, so it's 800,000, 801,000, 802,000, boom, there you go. You've just eaten 2.4 million tokens. Whereas if you're sitting down here in the sub 100K range, you're eating 80, 90, 100,000. And that's tiny in comparison. So up to the cache, you pay extra to put it in the cache. You pay 25% or 65% extra to put it in the cache for either 5 minutes or 60 minutes. And then if it hits in the cache, you pay 10% of the amount. And so you hopefully put stuff that's stable here. And when you have an append-only log, everything is already stable because you've already looked at it. So instead of paying 100% for this, you're only paying 10% for it, but most of it is garbage anyway. And they just keep doing that. Keep doing that. Keep doing that. And I looked at that and I said, this is stupid. Because almost everything in here is garbage. You don't need it. And so my question was, and it came down to asking about two things. One, a lot of this is garbage from the tool output. And Anthropic has figured this out. Claude Code actually now, they actually are pruning old tool outputs, and that gives it a longer context window. And I can do that too. I have a little projected gateway. I can literally sit this thing. It's a proxy as well. It's actually a gateway now. It's a gateway that sits between Claude Code and the Anthropic API. And all it does is it takes what Claude sends over here, strips out all of the garbage that it can, which is most of the tool outputs, and then sends that. You can get about 2x. You can get about twice as long before I run a context window. And so I said, what's left? What's left is the conversational state, the back and forth with Claude. and Claude says things, you say things, they go back and forth like that. Anything you copy paste into the conversation stays there permanently. You can't get rid of it. And that's why I said, what happens if and I've been working on this for a while, I said, can the transformer just keep a condensed set of information about what it's doing and what's important to it? Now, there's the way that this is always done, and I haven't been able to find anybody who's doing the way I'm doing. The way it's always done is that they do what's called a sidecar. I've got all this stuff here, all these conversations. And so what I do is I take that conversation, I give it to another model, and I say, would you please condense this down for me? And here's the thing that seems to be working out that way. Imagine if someone came in and made notes about your project and then gave it to someone else to use. Those notes are not going to look like what you would have written. And that is, in fact, exactly what I find. If I ask the model to create the notes in context, it creates something that looks different than if I ask someone else to come in and create the notes. I call it the biographer versus autobiographer model. And I said, okay, well, this is kind of interesting because I've done a whole series of experiments where you can have I replay conversations too, and you can actually watch the conversations, and the autobiographer stays stable in size, but the biographer, it keeps growing. At about 3 or 4 messages, I remember this because this number really stood out to me. It was like 40% larger for the biographer than the autobiographer. It's like, okay, well, it's only 3 or 4 hours. Maybe it'll actually catch up. By the time you get to 50, it's 2.5 times larger. Turns out it's also lower quality. So these chatbots that I'm now building, that's all they do. They actually just simply have this little state, and they keep track of what's important to them. And so you say something, we give the state, we give it what you said, and we tell it to tell us what it wants to answer back, and then anything it needs to update in its data structure. And so you do that, it comes back, and by golly, it stays stable. And not only does it stay stable, it actually becomes less sycophantic. You know what I'm talking about there. And Claude will just sit there and blow smoke. Like, you're like, really, Claude? What are you smoking? Why are you doing this? I call it on it all the time, and it admits it, and it knows it's there, but it does it anyway. It's actually a lot of fun. I find the AI interesting because I feel like we don't really understand how they work. Well, I know we don't really understand how they work. Explainability is a huge issue in the industry. But I look at it from a systems perspective, because I'm a systems person. I look at it and I go, why would you think that stuffing more and more stuff into a cognitive processing unit is going to be efficient? We know it's not. The problem when you send 1 million tokens to a large language model is that it's like imagine that I gave you 1 million pages of text to look through. Humans actually have the same problem, which is we remember the first thing and the last thing, and we don't remember the things in the middle. And this is a known issue with large language models. It's pretty funny to watch a conversation that has been going on for 3 days. And I have copied big documents in there, like 20, 30,000 tokens. And the entire thing is 7,000 tokens long and coherent. So I'm going to the next step, which is, okay, now let's give it tools so it can actually access the files. Because I've just been looking for the conversational part. Because I was working on the tool part before. Now I'm working on the conversational part. Now it's like, okay, how do I address both of these?
Is this Yanneted?
Actually, it's a storage engine. This one is Common-Tech. You can actually run it. I had to spend a little bit of time with, yesterday actually, I spent a little bit of time with Haiku. It took me about, I gave it a completely empty data structure. I said, put whatever you want in it. And like, it didn't really know what to put in there. And so I had to talk to it for a little bit. And then it started putting, and once it started putting things in there, boom, it was like talking to somebody different. A little brain transplant. Very interesting. Kind of fun to play with. I know you guys probably don't really care, but I'm happy to let you guys work on workshop, work on your paper, talk to you about your report if you want to think about that, or I can continue rambling. Let's see what we got. I actually copied it over here. I could actually run it. Let's see.
Is it just a report working time right now?
I'm sorry?
Is it just time for us to like?
Yeah.
run
I'm just here and I can answer questions if you want. Maybe I'll annoy you by showing you the this weird chatbot thing.
Thank you.
Have a good one. Actually, I think I could do it that way. Might be easier. I need to make sure I get that working. Do that.